New image from the James Webb Telescope shows that a simple planet like Mercury could be full of mysteries, including craters filled with diamonds. The discovery, which is due to the Sun, has scientists questioning their understanding of the universe's structure and its secrets. Recent studies suggest that diamonds may exist deep within the volcanoes, as well as being extremely large and variable. New technologies are beginning to reveal Mercury's secrets. NASA's Mariner 10 mission in 1973 and the Messenger mission in 2004 provided detailed images of a dense, porous planet with a magnetic field far more surprising and larger than expected, prompting scientists to update their understanding of Mercury. The Messenger probe, designed to orbit the planet, stayed in orbit, gathering a huge amount of data and capturing over 200,000 images, revealing parts of Mercury never seen before. Among the most interesting findings were high levels of calcium and magnesium on the darker side, leaving scientists wondering how these elements ended up there on Earth. Magnetic fields are created by the movement of liquid iron in the core, but Mercury's unique internal structure generates different magnetic properties. During the day, temperatures can rise to 800 degrees Fahrenheit, hot enough to melt lead, while at night, they can drop to nearly minus 300 degree F. Recent studies have shown surprising features on the surface, such as volcanic activity detected in 2012 and water ice found in some polar craters. These holes are so cold that the ice remains frozen, raising questions about the existence of simple life forms even in harsh environments. The Bepi-Colombo mission, launched in 2018 by the European Space Agency and the Japan Aerospace Exploration Agency, is headed for Mercury and will arrive in 2025. The planet will be amazed by scientists with its strong magnetic field, water signs, sugar, and the time difference model. For example, a year on Mercury is less than a day, so it's an amazing place to explore. Mercury is a slow rotating planet with a unique day-night cycle. Known for its unusual orbit around the Sun-Earth, takes only 88 days to complete one orbit, making the year very short. This slow rotation is thought to be caused by tidal locking, a feature of the Sun that slows the Earth's rotation by billions of years. Unlike our Moon, which is perfectly synchronized with the Earth's rotation, Mercury has a 3:2 rotation cycle, meaning it rotates 3 times for every second revolution around the Sun. The unique cycle of day and night creates the most extreme conditions on this planet, so that one side is exposed to the Sun for a long time, and the other side is very hot, dark, and cold. For a long time, Mercury was also thin. The atmosphere, known as the exosphere, is lost to space and replenished by sources such as the solar wind, radioactive decay, and the impact of small meteors. In 2020, scientists were shocked to find even more water vapor in the exosphere than expected, likely coming from reactions between hydrogen from the solar wind and oxygen in the rocky surface. Despite its small size and slow rotation, Mercury has a magnetic field, which was not something scientists expected. Recent studies suggest this weaker magnetic field is generated by a special process called the dynamo effect within its liquid metal core, influenced by Mercury's unusual orbit and rotation. This weaker magnetic field helps protect the planet from the solar wind, which would otherwise strip away its thin atmosphere even faster. Studies of Mercury's fast orbit and slow spin create bizarre conditions on the surface, such as hot poles, where the Sun seems to freeze in place in the sky, and water ice in cold, dark areas near the planet's poles. These icy areas have led scientists to wonder if other substances, such as organic matter, are also hidden. Studying Mercury is not easy because of its fast orbit and long days, making it a real challenge for spacecraft. The Bepi-Colombo mission, which began its journey in 2018, is currently on its way to Mercury, using the forces of Venus and Mercury to correct its course. However, the spacecraft must withstand extreme heat when exposed to the Sun and maintain energy during long cold nights. Recent studies have shown that Mercury rotates faster, but the Sun's force and collisions with larger objects such as asteroids slow it down. This gives scientists new clues about the universe's past and helps us understand how the planets of the solar system have changed over time. Mercury's massive iron core, which makes up 85% of its volume, is larger than Earth's core, which is only 15% of Earth's volume. Some experts, such as Dr. Nancy Chabad of the Johns Hopkins Applied Physics Laboratory and Dr. Erica Sfog of the University of Arizona, believes that Mercury is the largest planet. Earth's magnetic field, which is only 1% as strong as Earth's, was a remarkable discovery by NASA's Messenger mission. This discovery challenges previous understanding of magnetic fields in dwarf planets. Dr. Katherine Johnson, a planetary scientist at the University of British Columbia, and her team are still studying the case to learn more about Mercury's unique properties. Mercury's magnetic field is different, moving about 1/5 of the planet's radius. This is probably because the thickness of the Earth's crust is not the same, which affects the flow of heat inside the planet. In 2022, scientists discovered elements such as sulfur, potassium, and sodium on the surface. These elements usually disappear under extreme heat, so it's surprising to find them on a planet so close to the Sun. Dr. Patrick Peplowski believes that these elements may have come from comets or asteroids that hit the planet after its formation. Another amazing thing is the water ice in the craters near the poles of the planet. These protected areas are cold enough to prevent ice from melting. Those pits also contain organic compounds, molecules.
Mercury was thought to be dead. However, Messenger found signs of current volcanic activity, such as areas on the surface that may contain volcanic gases. Planet Antarctica is another mystery, with a wild and rugged land filled with hills and valleys the size of Texas. Dr. Amir Khan, who studied the data from the Messenger mission, discovered that the planet has a liquid exterior and a solid inner core, which could explain its unusual magnetic field. These discoveries challenge what we thought we knew about the formation and evolution of planets, and show that there is still much to learn about our solar system. The surface of Mercury, a planet with a complex history, is characterized by the absence of plate electric fields and the presence of cracks and faults. These unique features help us understand the past of the universe and its evolution. In recent years, scientists have discovered that Mercury's surface is constantly changing, with small, narrow valleys called grabens forming along larger cracks. A graben occurs when the Earth is stretched, showing that the surface is constantly changing and growing. The magnetic field on Mercury is different from Earth's and is probably created by a liquid metal layer surrounding a solid core that acts as a dynamo. Cracks and fissures under the crust can allow heat and liquid to flow in, and some scientists believe there is a water table beneath the crust that prevents freezing due to residual heat. Given the similar nature of other celestial bodies such as Europa and Enceladus, which have two oceans beneath their icy surfaces, this idea is not far-fetched. Exploring these hidden regions will generate interest and deepen our understanding of Mercury's formation processes. As we learn more, we are closer to unlocking the secrets of our world. How does Mercury change over time? What strange substances are hiding beneath the surface? What do these reveal about the early days of our solar system and the nature of the planets? These are important questions, and why we should continue to study Mercury. Each new discovery of what lies beneath the surface gives us more information about the planet and helps us understand how all the planets formed and changed over time. As scientists continue to conduct research and collect data, each new piece of information can change our understanding of space. Because of its extreme heat and proximity to the Sun, Mercury is a unique place to test our ideas about the nature and evolution of planets. The more we learn, the more questions we have, which keeps us curious and drives us to explore Mercury and the other planets. Thus, Mercury's surface, core and processes are key to understanding its fascinating history and the evolution of the solar system. As new instruments and technologies are developed, we will improve our ability to explore Mercury and other planets, allowing for further exploration and a deeper understanding of the universe.